Hi, I'm George Woodbury from College of the Sequoias, and in this video we'll talk about some different properties of summations as well as a few rules that could be helpful, especially when you get to calculus. The first property says that if we have a sum of a constant n times, we can just multiply n by that constant. So c is a constant number, like in example 5a down there you can see we're going to take the sum of 8 from I equals 1 to 27. Second property is if we have a constant multiplied by a member of a sequence, we can factor that constant out to the front and just find the sum of the sequence first and then multiply that by the constant afterwards. The last two tell us if we have a sum of a sum, we can find each sum separately. If we have a sum of a difference, we can find each sum separately and then subtract. On the right-hand side are a few rules for a few special cases where we're taking the sum of I squared, or I cubed. You want to have these formulas handy. The first one, n times n plus 1 over 2, is what you get when you take the sum of I from I equals 1 to n. And we'll talk a little bit about this one in one of the examples. There's also a formula for the sum of I squared and the sum of I cubed. And we'll use those in a moment. So first, let's start with this first sum, I equals 1 through 27, the sum of 8. And so if we wrote this out, we would write 8 plus 8 plus 8 plus 8, where there were 27 of them. Well, instead of doing that, we can just multiply 27 times 8, which is 216. For the second one, I equals 1 to 15 of 4i cubed, that constant factor of 4 can be moved out in front of the sum. So this is really the same as 4 times the sum of I equals 1 through 15 of I cubed. So what I use first is this property. Right? I factored out that 4 in front of the sum. What I'm going to use next is this rule that tells me what the sum of I cubed is in terms of n. It's n times n plus 1 over 2 all squared. So this would be 4 times, using the formula again, it's n times n plus 1 over 2 squared. So n here is 15. 15 times 16, that's 15 plus 1, divided by 2 squared. And we can simplify this a little bit first, or we can go right to the calculator at this point. I think it's going to be a little easier to simplify this. First, 2 divides into 16 8 times. So in the parentheses, we've got 15 times 8. And if you multiply that out, that is 120. And we're going to square that. Now, at that point, we happen to know that 12 squared is 144. So when we have 120, it's going to add on a 0 twice. This is 4 times 14,400. And then we can multiply by 4. And we should get 57,600. But I'm going to go back and go to the original and show you that in the calculator as well. So this was 4, and then in parentheses, we've got a fraction with 15 times 16 over 2, and then we were going to square what was there, and there you see it, 57,600. Also, if you did a little simplifying first, we could have done 4 times 120 squared. Same result. Couple more to do. The next one, it's going to be the sum as I goes from 1 to 12 of 9i minus 7. And so one of the properties tells me that I could break this up into two separate sums. So I could do the sum as I goes from 1 to 12 of 9i minus the sum as I goes from 1 to 12 of 7. You could also think of that as plus negative 7, but that's the sum of a constant, and we had a property for that. I can also pull this 9 out to the front of this sum, and I'm going to scroll back up to the properties to show you the 3 that we're using here. For the sum of 9 times I, I'm first using this one, multiplying, pulling that 9 out to the front of the sum. The sum of I can get from this formula, which you'll notice is just like the formula for I cubed, except there's no squaring going on. N times n plus 1 over 2. And then finally, for the negative 7 part, I'm going to use this one, where I can just multiply n times that result. All right, let's go back and finish this one off. 9 times n plus 1 over 2, that's the sum of I, minus 12 times 7, n times 7. N was 12, so I can substitute that in. 9 times 12 times 13 divided by 2, minus 12 times 7. Let's see, 2 goes into 12 6 times. And 6 times 13 is 78. So what we really have here is 9 times 78 minus 12 times 7. Continuing by hand, that's 702 minus 84. And that should be 618. But let's go to the calculator to do this. 9 times the fraction 12 times 13 divided by 2 minus 12 times 7, and there we have it, 618, which is what we have. All right, one last one to do. Maybe we'll try to use the calculator a little more this time. We're going for I equals 1 up to 7, and we've got 3 terms here that we can break up. We've got the sum of I squared. We'll have the sum of 8i, so that tells me I can pull the 8 out of that. And we've got the sum of a constant 12. So first, let me split this up into 3 sums. I equals 1 to 7 of I squared plus 8 times the sum I equals 1 to 7 of I plus I equals 1 to 7, the sum of 12. So the only one of these that we haven't used yet is the sum of I squared. Let's go take a look at that formula. That's got a little more to it. It's n times n plus 1 times 2n plus 1, all divided by 6. So I'm just going to make a quick note of that formula here. N times n plus 1 times 2n plus 1 divided by 6. That's for I squared. We already know the one for I is n times n plus 1 divided by 2. So for I squared, that's n, 7, times n plus 1, which is 8, times 2n plus 1, which is 15. And that's all going to be divided by 6, plus 8 times, for I, it's n times n plus 1 over 2, so that's 7 times 8 divided by 2, plus we're going through this sum 7 times, we're adding 12 7 times, so that's 7 times 12. Now, we could try to clean this up a little bit, or we can go right to the calculator. There's some advantages to cleaning it up first, in that the numbers you're working with are going to be smaller and easier to work with, less to type into the calculator. But if you make a mistake there, you're going to be in trouble. You can go right to the calculator, but typing in all of these expressions, there's a chance for a mistake there too. So you've got to try to weigh that out. I'm going to try to simplify some things first. 7 times 8 times 15 over 6. I know that I can divide 2 out of 6 and 8, giving me 3 and 4. And then I can also divide 3 out of 3 and 15. So this first term is really 7 times 4 times 5. For the second term, I can divide 2 into 8 4 times, and that leaves me with 8 times 7 times 4, and finally 7 times 12. And these I can actually do without the calculator. In the first term, I know 4 times 5 is 20, and 20 times 7, that would be 140. The next one's a little more challenging. 8 times 7 is 56, times 4, that should be 224. 7 times 12 is 84, and we should get 448. But what I'm going to do on the calculator is come back to this, the original, before I reduced anything. All right, we had a fraction of 7 times 8 times 15 over 6 plus 8 times a fraction where we had 7 times 8 over 2 plus 12 times 7, and there's that 448. So there are several examples using some of the properties, adding a constant, factoring out a constant, breaking a sum into multiple sums, as well as the formulas for the sum of I squared, or I cubed. That'll do it for this section. I'll see you in the next section where we talk about arithmetic sequences and series.